Hello viewers, in this session I would like to discuss on multi-degree of freedom system. The theory of multi-degree of freedom system is applicable to all kinds of structural systems, whether discrete structural system or continuous structural systems, which are idealized as equivalent discrete structural systems. Normally, the multi-story buildings are modeled and analyzed as multi-degree of freedom system. To transform the building structure into a discrete number of degree of freedom system, the lumped masses at each floor level is considered to be lumped at each particular floors, including the self weight as well as the dead load or end live load. For this, the assumptions are necessary. We have to assume the structure to be in particular format. In that, the entire mass of the building is concentrated at each floor levels, maybe floor 1, floor 2, floor 3, based on the number of stories in the structure. The axial forces do not contribute significantly for the deformation of the structure, which is very stiff. And the third assumption, the floor with slabs and beams are infinitely rigid as compared to columns, and which remains horizontal without having any rotations. So on this I would like to take some example to discuss here. I do consider a 3-storied structure. This is a 3-storied structure, and I would like to connect these stories as a representing columns. Representing the columns, and this would be considered as a foundation. So on this, after the analysis, I do expect to have some of the forces acting on it. So at this floor, second floor and third floor. In the first floor, the force 1 with respect to time it is acting, and force 2 with respect to time it is acting, and force 3 with respect to time it is acting. And each floor has lumped mass 1, mass 2 and mass 3, and the stiffness of each columns, this I will take K3 since the third floor, K2 and K1. So once these mass systems or the floor levels are experiencing the force with respect to time at each floor level, so each of these masses will deform, or will expect some deformations within this. So now the deformations are expected to have in this direction. As the force is acting in this direction, the deformations are also expected to have in this direction. So on this, I would like to take this as x1 deformation, x2 deformation and x3 deformation. So these deformations occurred, then the structure is expected to have the deformation like this. So this will be the mass m1, and this will be the mass m2, and this will be the mass m3 at x3 displacement, and mass m2 at x2 displacement, and mass m1 as x1 displacement. So I will take this as the first diagram. So now I will take the free body diagram of this structure. So for that, what I do, I will take this first one, the m1, when the force F1 of t is acting on this floor, F1 of t is acting at this floor, the mass with acceleration is acting opposite to that, and the stiffness and the displacement is acting in the same direction. Means when the force is acting on the particular mass or a lumped mass, the opposite forces which are acting means the resisting force which are acting through the mass is xk1 and x1. And m1 x1 double dot. At the same time, we got another floor which is attached to that, which is m2. So again the force of F2 of t is acting, and the force F2 of t is acting, the resisting force K3 of x3 minus x2 is resisting, and at the same time here K2 of x2 minus x1 is resisting. Along with this, there is a mass 2 with x2 double dot, and at the same time I got one more lumped mass which is acting which is there at the third floor, and on this also this F3 and 3 with respect to time is acting, and here the resistance force is m3 x3 double dot, and this is again resisting with K3 times x3 minus x2. So this is what the free body diagram which I can take. So now on this equation of motion for the multi-degree of freedom system with negligible damping which is c equal to 0 for free vibration, means f of t with respect which is 0 free vibration. If I want to write, then I could take this like the equation of motion for each of the lumped masses. This is m1 x1 double dot. So I am writing for this one. Here I do take this direction sign as positive and this direction sign as negative. For this m1 x1 double dot, and again the plus k1 x1 and minus k2 x2 minus x1. Since it is a free vibration, the forces are not considered, which is equal to 0. So m1 x1 double dot, this part which I have written, and k1 x1 is this one, right, and k2 x2 minus k2 times x2 minus x1 is this one, right. So again this is acting in this direction now, and f of f1 of t which is equal to minus, so that is completely referred as a 0 since the free vibration. And now if I want to write it for second one, so m2 x2 double dot plus k2 times x2 minus x1 minus k3 times x3 minus x2 which is equal to 0. So how I have written this one? So considering this second one, m2 minus m2 x2 double dot which is in direction plus, and again I have this one k2 times x2 minus x1, this part, and now this k3 times x3 minus x2 is acting in this direction which is minus, and f of 2 times t which is 0 since it is a free vibration. So now I do consider the third one, m3 x3 double dot plus k3 times x3 minus x2, which is equal to 0. So this is the equation of motion for multi-degree of freedom system by referring the free body diagram of the 3-story structure. So now I would like to write this equation in the form of equation of motion itself. To write that, first I will take this as the equation 1, equation 2 and equation 3. So equation 1, if I want to write, I am just rewriting this equation, m1 x1 double dot plus k1 plus k2 times x1 minus k2 x2, which is equal to 0. So what I have written, I have just rewritten the equation 1, m1 x1 double dot written as it is, k1 plus k2 times x1. This k1 x1 is written as it is, and k2 x2. Now if I multiply this one, this is k2 x1 minus into minus plus, and now if minus k2 x2, right? So this is k1 x1, this is m1 x1 double dot, this k and this k is common for x1, so k1 plus k2 are taken into bracket for x1, and remaining is k2 minus k2 x2, which is minus. So now similarly, if I want to write it for second equation, m2 x2 double dot plus, which is minus k2 x1 plus k2 plus k3 x2 minus k3 x3, which is equal to 0. In a similar way, I would like to write the third equation, which is m3 x3 double dot minus k3 x2 plus k3 x3, which is equal to 0. So now the equation 1, 2 and 3 are rewritten and multiplied all the brackets. So now I would like to write the equation of motion for this. So the mass systems I do write. So m1 I do not have for x2 and x1, and for in the second equation I do not have for x1 with associated with m, because it is 0, and x2 has associated with m2, and I do not have x3 double dot in this equation, and x1 double dot is not associated with m, x2 double dot is not associated with m, x3 double dot is associated with m3, right? So now x1 double dot, x3 double dot, x2 double dot and x3 double dot, right? This one plus stiffness matrix I want to write. So now in the stiffness matrix, x1 is associated with k1 plus k2. So now I will write k1 plus k2, and x2 is associated with minus k2. This is minus k2. So I do not have x3 here in the equation 1. I will take it as 0. Now for equation, in this equation, I will write x1 is associated with minus k2 here, this one. x2 is associated with k2 plus k3, which is plus k2 plus k3, and x3 is associated with minus k3. Now in this third equation, x1 is 0, I do not have x1. x2 is associated with minus k3 because I am writing stiffness matrix minus k3, and x3 is associated with k3. Alright, this is what. So now this would be multiplied with x1, x2, x3, so which is equal to 0 because it is free body diagram. So now this equation could be written as mx double dot plus kx, which is equal to 0. So this is the equation which you can refer as equation of motion, equation of motion for a 3-story building with mass lumped at each floor and stiffness k1, k2, k3, and forces acting as F1, F2, F3, which is considered to be free vibration. So now in this way we can represent the equation of motion for a system. Thank you.